Terraform 1.5 includes the new import block, and it's a game changer. The new feature makes importing existing infrastructure far easier than the older import command. Let's dig into how it works, why it's better, and what gaps still exist. Welcome to Terraform Tuesday. Hey everyone, I'm Ned Bellavance, nedinthecloud.com, and welcome to another episode of Terraform Tuesday. I even got my taco shirt on. Today we're going to be talking about the new import block in Terraform 1.5. When you first start using Terraform, there's a non-zero chance that you already have infrastructure deployed, and you may want to bring that existing infrastructure under management with Terraform. Now, while that was possible with the older import command, it was quite painful. The older process for importing resources into Terraform management used the import command. Now, the workflow went like this. You would first run the Terraform import command with the desired address of the resource in your configuration and the unique identifier of the resource in the existing environment. The import command would pull the existing resource and gather the attributes of that resource, and then it would create a state data entry for it using the desired address you specified. It would not create the resource configuration block in your Terraform code. That was up to you. The next step was to create that resource block yourself and run a Terraform plan to see if any changes were required. Now, if you did everything right, usually you didn't the first time, but if you did everything right, you would see no changes required as the output, and you could safely run a Terraform apply to bring that resource under management. There were several shortcomings to using the import command. First of all, the import command directly edits the state data without generating an execution plan first. You don't have a chance to preview changes before they're made, and that's not great. Even worse, between the time that you ran that import command and the time you successfully added the resource block and applied it, your imported resource was in a precarious position. Why is that? Let's think about what Terraform sees if someone ran a Terraform apply before you added the resource configuration block. Terraform would see a resource in the state data that was not in the configuration. How does Terraform interpret that? Well, it would assume that the resource was deleted from the configuration, and so it would attempt to destroy the actual resource. That's bad. Now, it's unlikely that you would do this to yourself, but if you're in a collaborative environment with remote state, you better make sure everyone knows you're importing a resource and to pause on any work until you're done. The second big problem is that the import command only allowed adding a single resource at a time. If you had a lot of resources to import, you had to run the import command over and over and over again. And every time, Terraform would have to establish a connection to the existing resource and its provider, gather up its attributes, and add them as a state data entry. Importing 100 resources could take an hour or more, even if you got all the import commands right. Side note, as we already discussed, each of those import commands would alter state data without producing an execution plan. So not only do you have to get the commands right, you have to get all of the commands right. Lastly, the import workflow required you to generate the resource configuration blocks yourself. That's not a showstopper, but you'd think since Terraform can see all the attributes and it knows the structure of the resource, it could probably make a guess. It could generate a basic resource block for you. But the import command didn't. Guess what? The new import block solves all of these problems. The new import block is essentially a replacement for the import command. It was introduced in Terraform 1.5, and the process is similar to any other modern Terraform workflow. First, you add the import blocks to your configuration. Now, the syntax for the block is dead simple. It's the keyword import, no block labels, the curly braces to signify the beginning of the configuration block, followed by a to argument that specifies the desired address of the resource in your configuration, and then an ID argument that specifies the existing resource's unique identifier. And that's it. Once you've added your import blocks to the configuration, you run a Terraform plan to see what changes will be made. If you're happy with the plan, you run a Terraform apply to bring the resources under management. Once you're done, you can remove the import blocks from your configuration. You can add as many import blocks to your config as you want, so you're not limited to one import block and process at a time. And you'll see the proposed changes to the state data, as well as any changes to the imported resources based on what's in your configuration. Now, typically, you would not want to see any changes to the imported resources because you want to make sure that the configuration matches the actual existing resource. Now, since it's a purely declarative process, if someone else is also working on the environment, you won't have a situation where changes have been made to the state data, but the configuration isn't updated yet. It's all one or none. That's probably a much better workflow. What about the creation of the resource blocks themselves? Well, there's now an experimental feature that will help you generate the resource configuration blocks. It's a new flag with the plan command called -generate-config-out, and you set it equal to a file where you would like those resource blocks to be created. Terraform will first query the objects based on the import blocks, generate the configuration, and then run a standard plan to validate the generated blocks and detect any changes. You can review the contents of the blocks, make alterations as necessary, and then run a plan without the generate config out flag to see the results. As we'll see in one of the examples, this is still an experimental feature, so it's likely to get some portion of the resource configuration wrong. But it does give you a good starting point to build out your configuration. Let's dig into a couple examples. As always, the code for the examples in this video are available in the description below. For our first example, we're working in the directory 2023-0711 import block. I've got two directories in here, one that's import subnet example and one that's import with generate. We're going to be doing the import subnet example first. I'll expand that out, and there's an existing Terraform configuration in here that uses a network module to generate a virtual network in Azure that we're managing with Terraform. Now, I have already run a Terraform apply to create that virtual network. The virtual network has two subnets in it. If we look in the main, I have my module here that uses the source of /network. That's the network module in the subfolder. And it specifies a virtual network name, an address space, and then some subnets that we want to create in that virtual network. Looking in the terraform.tf vars under the subnets value, we have two subnets that were created, web1 and web2, each with its own IP address range. Now let's say that someone requests a new subnet, and you have a junior admin. Let's call them Chris. Now, Chris doesn't know about Terraform, but they're trying to be helpful. So they pull up the terminal and they use the Azure CLI to add a third subnet. Now I have that command in commands.sh. So we will run this command here. There we go. And that will add a third subnet called web3 to our existing virtual network. Now, in order to properly use the import block, we're going to need the ID of that subnet. So I'm going to run a second command here from the Azure CLI that will get that ID. Let me copy that, paste it down here, and that should give us just the ID of this third subnet that we just created. Now, crap, Chris, that's not how we do things. Now we have a subnet in our existing virtual network that's not under Terraform management. We need to bring it under management, and we can do that with the import block. In the imports.tf file, I have a commented out import block. So let me remove the /* to uncomment the block. You note the block starts with import as the keyword. The 2 specifies where we want to import this resource to. And since I'm using a network module that can dynamically add additional subnets based off of the values I supply, I'm going to identify that I'm adding it at the address module.main.azurermsubnet.main and then web3 because it uses a for each loop to create those subnets. So you can add it to an existing module or a resource configuration block directly in the root of your config. It's really up to you. The ID is going to be the subnet ID that we just got using the Azure CLI. So I'll copy that value and I'll paste it up here. That's everything for our import block. The other thing we need to do is update the value for our subnets to include that third subnet in the value. So what I'm going to do is go to tf-vars and uncomment this third subnet. So now we have 3 subnets that we want to create. Now, what's the next part of the process? If we go back to the commands, the next thing we're going to do is run a Terraform plan. So let me expand up the terminal so you can see the entire output. I'll run a Terraform plan here. It's going to see that import block, and it's going to let us know that it's going to import that existing resource into our configuration once it's completed the plan process. Now, if you're not sure what address to set it to, one thing you can do is use a Terraform state list to get the existing entries in your state data, and that can help you figure out the address format that you need for the import block in the to argument. Okay, it has successfully run the plan, and if you look at the output of the plan, it tells us it has 1 to import, nothing to add, nothing to change, and nothing to destroy. That's exactly what we would want to see. So now we can run a Terraform apply to successfully import that unmanaged subnet into our configuration. Once that apply is complete, it'll be added into state data. We're good to go. The last thing to do would be to go back into the imports here and remove this block for the import. You don't have to do it right away, but you do want to remove the import block eventually. Skipping ahead a little bit in time, it has successfully applied the import, and we are now managing that third subnet. So I will now comment out the import block. There we go. So it is no longer part of our configuration. Now let's look at how the generate config out works. For the next example, in this case, we have a deployment in Azure that was created with an ARM template. Now we want to bring those resources under Terraform management. We'll use the generate config out flag to create the resource blocks for us instead of doing it manually. Now, I've already used the Azure CLI to create a resource group and deploy the ARM template. If you're following along, in the directory import with generate, there's a subdirectory called create Azure resources. In there is the ARM template file. It creates resources like the virtual network, the subnet, the Azure virtual machine, a public IP address, a network interface, and an NSG. So it creates all those resources for you. To run the actual commands to generate those resources, that's in the commands.sh file. And that essentially has you create a resource group called Taco Truck, use the AZ deployment group create command to create all the resources that are in that ARM template. And then the last command here will query the properties of that deployment to get the resource IDs of all the resources that were created and put that into a file called table.txt. So this table.txt has all of the resource IDs, and we're going to need those for our import block, which I have a little further down here in the imports.tf file that's in the main directory of import with generate. In this file, I have created all the necessary import blocks for each resource that's going to be imported. For instance, the first one is going to an address of Azure RM virtual network.main. Now, right now, that resource block does not exist. We're going to ask Terraform to do it for us. The ID needs to be set to that virtual network identifier, which is contained in the table.txt. Now, I'm not going to make you watch me copy and paste each value from the table.txt, so let's jump forward to when I've done that successfully. All right, I've successfully copied over all the IDs. I do want to point out one of the resources that is a little funky, and that's the association of the network security group to the network interface. That's its own resource called Azure RM Network Interface Security Group Association, and the ID takes the format of the network interface ID, and then the pipe symbol, and then the network security group ID. It's always a good idea to check the documentation for a particular resource and see what the unique identifier is for that resource, because, like this one, it can be a little bit funky and non-intuitive. Now that we have all of our import blocks ready, the next step is to run Terraform plan with the generate config out command. And I have that in commands.sh. So let me bring up the terminal here. I've already run a Terraform in it to initialize this configuration. So I'll simply grab the Terraform plan with the generate config out flag, and I'm going to send the results to a file called generated.tf. That has to be a non-existing file. This is going to create a file on its own. So I'll run that command, and what it's going to do is reach out to Azure, and it's going to query for the attributes of each of the imported resources, and then create configuration blocks for each of those resources in the generated.tf file. And then it runs a plan to verify the information that's in that generated.tf file. Now, this can take a moment to do all that querying, so I'll jump forward to when the command completes successfully. All right, the command has completed, but it hasn't completed completely successfully. I've got some errors here. And let's take a look at the first one, or the last one that was printed out. That says, in the object Azure RM Linux virtual machine.main, platform fault domain, all of platform fault domain and virtual machine scale set ID must be specified. Let's take a look in generated.tf and what's going on with that particular object. Now I'll hide the terminal for a moment so we can see the full view here, and let's scroll all the way down to this virtual machine. Here we go. And it was talking about the platform fault domain, which is currently set to -1. Now, if you look at all the information that was pulled in here, a lot of them are set to null or set to a default value, and this might not necessarily be a valid configuration. It's literally just copying over the attribute values it sees when it queries the provider. So something like the platform fault domain of -1 is not a valid value. So what I'm going to do is just comment out that line, pull the terminal back up, and it seems like there's a few different errors in here. I can generate those errors again by running a Terraform validate, and that will look at those configuration blocks and kick back any errors that it sees. So what you're going to need to do after these generated blocks are generated is clean up some of the stuff that Terraform doesn't quite understand. I did say this was an experimental feature, didn't I? So let me jump forward to when I've cleaned up some of this configuration, and we'll try going through the plan and apply process. Okay, it actually wasn't too bad. I had to comment out the service endpoint policy IDs argument because it can't be empty. I also, in the virtual network, had to comment out the flow timeout in minutes, and I had to remove the subnet block that was added to that virtual network because we're defining our subnet separately in its own resource configuration block. So that's all the cleanup I had to do. It wasn't terrible, but there was some information I needed to take care of. Now you note all the entries here are static in nature. They're hard-coded into the configuration blocks. So the next step would probably be going through the process of turning some of these at least into input variables. The other thing is, it does not have any references from things like the virtual network to the subnet. So Terraform doesn't know that the subnet is related to that virtual network. And that can definitely be a problem when you need to update or destroy or remove things. So you would either have to add a depends on here, Or like this virtual network name should instead be set to a reference of the existing resource, the Azure Virtual Network. So those are some caveats that you're going to need to deal with if you're going to use the generate config out flag. So now let's run a Terraform plan. And this time we're going to skip the generate config out argument because we've already done that successfully. And let's just validate that our plan runs successfully and it's simply importing things and not changing any of the existing resources. Okay, that took a minute, so I jumped forward so you can see the output, and it looks like it's telling us there are 7 resources to import, 0 to add, change, or destroy. So this is a good starting config, but you would definitely want to do some work on this configuration after you've successfully imported all this. So I'm going to run a Terraform apply with the auto approve flag because I'm feeling confident. I'm feeling pretty good about this. And once this apply is finished, we are now managing this existing Azure infrastructure with Terraform. The import block is a great addition to Terraform because it makes the process of importing existing resources declarative and predictable. It's a definite improvement over the old import command, but that doesn't mean it's perfect. The generate config out flag is still very much experimental, as you saw, and it's not going to get everything right. And it doesn't understand resource dependencies, resource references, or anything else that's not a direct attribute of the resource. So you are going to have to do some amount of manual work to get the resource blocks right. Also, the import process doesn't discover your existing resources for you or extract the unique identifiers that you'll need. You still have to do that yourself. Now, that's not a big deal if you're just importing a few resources, like in our subnet example. Or we were lucky enough to be able to query the ARM template for all of the IDs in that case. But if you have to import everything that's in like an Azure subscription or an entire AWS account, that could be a huge pain. There are some excellent third-party tools out there that can help you with that. For Azure-specific resources, there's the Terraform export tool, which is formerly called Azure Terrafy. I did a whole video on that a while back. The team maintaining the tool has looked into how they can incorporate these new import blocks into the existing workflow. If you're on AWS or GCP, there's the Terraformer tool, which I had some trouble with a few years back, but I hear it's gotten a lot better. There's also a bunch of vendors who offer commercial tools to help with this process. One such tool that I'm pretty intrigued by is Firefly. They seem to do a lot more than just import resources, so stay tuned for a possible future video on that. HashiCorp has been slowly moving all Terraform operations to a declarative first approach, and now the import block is a great example of that. It's been a big ask from folks for a long time to get better import support, and I am excited to see it get the first-party support in Terraform Core that it truly deserves. Thanks for watching this video. If you enjoyed it, why not like, subscribe, and maybe even share with a friend. If you want another video to watch, I recommend the video I did on moved blocks, which is another way they're getting around the previous non-declarative approaches. And I've also got a new series that's all about Terraform basics, if that tickles your fancy. Thanks for watching. Until next time, stay healthy, stay safe out there. Bye for now.